So in this exercise, we are going to deploy a simple service, web service, in the virtual environment of VirtualBox hypervisor. Okay, could you just look from this projector, okay? Would it be okay if I don't share the screen with you?
Yes.
Okay, excellent. So basically, here we perform the virtualization. Why virtualization? Because, you know, the basic cloud infrastructure is in virtual environment due to cost decrease and many other factors. So in this exercise, we are going to simulate this, let me say, cloud environment, and we are going to implement on Linux CentOS operating system, Apache 2 web server, okay, and many other things. You'll see. So in this way, we are like simulating the cloud infrastructure, because in cloud environments, when we rent CPU, we basically rent a virtual machine, and on this virtual machine we set up like our web server. So that's what we are going to do here. So here you have this CentOS 7 minimal installation. So please run VirtualBox. So just start the application. So VirtualBox is what? It belongs to the special group of software that are called hypervisors or virtual machine monitors. So it's basically the software that performs various tasks with virtual machines, like by using that software we can create virtual machine, we can terminate virtual machine, we can upgrade virtual machines, and more importantly, this software chooses which virtual machine and when it will communicate with the physical hardware infrastructure, because basically by using virtualization, many virtual instances or virtual machines are sharing the same underlying physical hardware architecture. Okay, we are in next lectures we are going to discuss about virtualization in more details. But for now, I want just to tell you that the Oracle VirtualBox hypervisor belongs to the group of level 2 hypervisors. What does it mean? It means that it runs on the top of operating system. So not directly above the physical hardware infrastructure. So it runs above the operating system, and from the operating system perspective, type 2 hypervisor is just like any other application. So like Word, like Excel, like Adobe Photoshop or some other application. That's how the operating system perceives the VirtualBox. So it's type 2 hypervisor. However, we also have type 1 hypervisors. These are special hypervisors that run directly on top of the hardware. What does it mean? It means that we do not have to install any other operating system like Windows, Linux, Mac OS X or whatsoever. So we install level 1 or type 1 hypervisor as the main operating system. The most important representative of type 1 hypervisor is VMware ESXi hypervisor, and also we are going to do some exercises with that. I also have already published some video tutorials for that. So basically, I have implemented this type 1 hypervisor on virtual machine, because otherwise I would have to erase my basic operating system to like perform some kind of dual boot and everything, so it would be like too complicated for this simulation. Okay, but we are going to do. So it's level 2 hypervisor. Okay, so now first we have to create, have you worked with Oracle VirtualBox before?
Yes.
Okay, so David knows. This is the first time for Georgia to meet this environment. So first we have to set up the virtual machine, in virtual machine, like a physical machine, has like all components. It has a vCPU, virtual CPU, it has a virtual memory, it has a virtual storage and everything. So a full-fledged virtual PC can be implemented by using the Oracle VirtualBox. So first, please click on this new button. And in this very first step, we should give a name for our virtual machine. I'm going to name it like CentOS 7 because we are going to use CentOS 7 operating system. Apache 2 web server. Why? Because we are going to implement this Apache 2 web server on this CentOS machine. And you see here, the VirtualBox recognizes that it's Linux. And now it will be good if we more precisely specify what kind of Linux this is. I'm going simply to choose this option, other Linux 64-bit, because it's 64-bit operating system. As you can see, it's 64-bit based on this image file, okay? And I just click next. Now we should delegate amount of RAM memory to our virtual machine. Basically, what happens? It happens that we basically borrow random access memory storage from the physical machine to our virtual machine. So basically, you see, it's a sophisticated system. We have here this Windows, and in the virtualization terminology, this Windows is called a host operating system because it hosts virtual machines and everything. And that operating system that we are about to install on the virtual machine or virtual instance is in the literature of cloud computing called guest operating system. So in this way we can, differentiate between the basic operating system and the, this operating system on virtual machine, which is called the guest operating system. That's like a little play with terminology here. So let's choose the amount of RAM memory for this purpose, since, as you know, as we have already been discussing, Linux is light-weighted operating system. What does it mean? It means that it consumes few resources, which is very good, especially in cloud environments, because most of the world servers are on Linux, because it's light, it consumes so much, so few resources, and that's it. And most Linux server implementations do not use graphical user interface. They use just so-called CLI interface, command line interface, yes, because which part of operating system consumes the most resources? Graphical user interface. So we don't need it. Okay.
Like Windows, too much.
Yeah. So please click next, and now in this step we will create a virtual drive. Just click create. So there are different options for virtual drive formats that we can specify. This VDI, VirtualBox disk image, is from the VirtualBox, so Oracle implementation. VirtualBox is a software from the company Oracle. You know that? So VDI is from Oracle. This VHD is a Microsoft's format of virtual disk. So it stands for virtual hard disk, as you can see. And this VMDK is virtual machine disk. It's from the vendor called VMware. Okay, so you can see that Oracle VirtualBox supports cross compatibility. So it means that it also supports image files from other vendors as well, which is very good. And also, we'll do some exercises with Microsoft Hyper-V hypervisor. You will see that this hypervisor supports virtual disk format files from other vendors. But for this purpose, let's just choose VirtualBox disk image from Oracle. and please click next. And now we have two types of virtual disks to choose from. First is dynamical disk, and the second is fixed disk. So, do you know what is the difference between the static and the dynamic disk?
When it's static, you can't change it. Dynamic, you can change it.
Okay, so look here, please.
No.
Okay, so which type you will choose depends on the requirements. So if we choose a fixed or static, some vendors call it static, you see. If you choose a fixed or static disk type. And for example, if you want to create a virtual drive that is 500 gigabytes in size, for example. So 500 gigabytes. A virtual disk is nothing more than one file on your physical disk. It's simply one file. And then, for example, if you want to plug this disk into other virtual machine on other host computer, we can like copy this on USB flash drive and take it to other machine and just import it.
How much memory does it use?
We need like 25 gigabytes, but that we'll choose the next step. So, if we choose a fixed or static disk, it means that Oracle VirtualBox will create for us a file on physical disk that is 5 gigabytes of length. It will simply put all zeros because at the beginning there will be no content in this disk. So it will allocate immediately upon creation a chunk of 500 gigabytes from our physical disk. So for our host operating system, this 500 gigabytes chunk will not be available. So, however, when we use fixed disk, so it takes some time to initialize all these zeros, zeros. So the process of creation of fixed or static disks will take some time. Okay. However, later on, when we install operating system, install services, and all other things, it will be much faster because it's already been allocated. Okay. However, we also have the second option. It's dynamic disk. So, in the case of dynamic disk, if we again choose 500 gigabytes to be the size of our dynamic disk, at the beginning, this file will be so small, close to zero, and then as we install operating system, install services and everything, it will, grow up to size eventually of 500 gigabytes. So it means this file will be dynamically growing during the usage of our virtual machine. So what are the pros and cons of this solution with dynamic disk? The pros would be that at the beginning we will have more storage of our physical disk to use, because it will be 1 megabyte, 2 megabytes. As it grows, we will have less storage, but we will have more storage to use. For example, if we say our dynamic disk can be up to 500 gigabytes. If you use only 100 gigabytes, so we'll have 400 gigabytes of our physical drive intact. But in the case of dynamic disk, if we say that we need a 500 gigabytes disk, and if we use, let's say, just 100 gigabytes, all 500 gigabytes, despite of the fact that we are not using all 500 gigabytes, we will not have available for our host operating system. Okay. So this will be the pros of dynamic versus fixed or static virtual disk. However, there are some cons, of course, because in everyday life, the same in computer science, we have advantages and drawbacks. Yes, of course, yes. The drawback of dynamic disk will be that when you start installing applications, services, operating system files and so on, it will take some time for this disk to grow. So the process of exploitation of that disk will take more time than in the case of fixed disk, because it will take some time for this file to grow. You get it?
Yes.
So it depends on needs. And one more thing that I want to share with you is that in the modern era of computer science, we have solid state disks. So they're very fast because they're electronic devices, they're not mechanical. So, you know, this advantage of dynamic disk is not so important in modern era. However, if you install a sophisticated infrastructure in cloud provider facility, they always use fixed sizes because they want to be as fast as possible. Okay. But in this case, we're going to use dynamic, for example. So dynamically allocated disk, and click next. And now, okay, here we could just choose a location where we want to store our VDI file, that's virtual disk. I'll just leave default location, but you may choose your own location if you like. And for CentOS, we are going to need around 25 gigabytes of size at minimum. So I'm going to choose 25 gigabytes. Okay?
Do we use big size or dynamic?
I've chosen dynamic size, but you may choose fixed, it will be the same. Okay.
Because the interface is different from yours.
Okay.
Everything is on one
Yeah,
screen.
on Mac, yes. It's a little bit different, yes. Have you used this new iPhone?
No.
Okay, I heard good things about it. But, and this new Apple Watch, Generation 5, yeah, it's good also.
I just heard about it, it's too much right now.
Yeah, I know. I've heard good things about it, but I read it. Okay, so let's click Create. And now we've created our virtual machine. Okay, we've created our virtual machine. And now we have to set up a few things. So we're going to do many exercises with virtualization. So for now, I'm not going to go into details. For now, just right-click on virtual machine and choose Settings, please. First thing that we want to do is to insert a virtual DVD drive with our Linux installation. Like in physical computer when we, just put the disk in a drive, now we have to put a virtual DVD or some other disk into the virtual drive of our virtual machine. So for that purpose, please go here to Storage. And here on this button, where it says it's ID, Integrated Device Electronics Controller, just click here on this first plus sign, and then choose disk. Choose disk. And I'm going to choose disk CentOS minimal installation. Have you chosen this?
On this computer I don't have that option.
It's a bit different.
Let's check. Okay, good. So David? Okay, good. Okay, good.
Put it on the second one.
Okay, that's fine. Okay, so now let's check one more thing before we start. We boot up our virtual machine. Let's go here to network, please. And as you can see, we can make available up to 4 virtual network adapters. That's basically network interface cards, like network cards. However, by default, only one adapter is enabled, you see. But for this exercise, we are going to need only one adapter, and that's fine. So if we use like a VirtualBox in console, it has its console interface. We're not going to use that right now. We can enable up to 8 network adapters. So like a full-fledged server with 8 network cards. It's awesome. Okay. So here we choose the type of virtual network. Today I'm not going to discuss about it. We have some upcoming exercises for that. But for now, please just leave it as NAT. It stands for Network Address Translator. And if we set this network adapter to be a NAT type, it means that, I'm going to explain you later on in detail, it means, but for now on, please know this. When you set up a network interface card as NAT, Network Address Translator, it means that we can connect our virtual machine with the internet. And that's what we need. Okay. It's like adapter for internet connection. Okay. Now click OK, please. And now we have to start up or boot up our virtual machine by clicking on this Start button. And just choose this first option. So choose this first option, install CentOS 7. We don't want to test it, like live boot option, we want to install it. Install. And we wait, and the installation process will begin shortly. Okay, so it's time for break, okay? So we're taking a break at every 45 minutes. Is that okay? Okay, I'm going to pause this recording for now, and then after the break, we'll continue. So, Stefan, you will see this screen when we start our installation. There are a few tricks with install. Okay, it takes some time. It takes some time, to load all files and so on. So when the installation process starts, a so-called memory image is being created in the random access memory. So all files necessary for installation of the operating system are copied into the random access memory, and this is performed by the process called the bootloader. You've heard of this, yeah, you had operating system theory, so you know everything. So when we come to this screen, I'm going to choose English language, and this English United States, it's fine. Just click continue, please. Okay. Are we all in this step? Okay. Now we have to do some things. Localization, time zone. I'm going to choose the region Europe and the city of Belgrade.
What did you pick?
Done. Just this date and time. That's it.
No.
Network time or?
Just this date and time. And it shows Belgrade and region Europe and the city Belgrade. And click on this done button. This software selection, it's minimal. You know why minimal? It means that we are about to install a CentOS with minimal software configurations on it. That's because we want to install everything by ourselves. Okay? Done. Click here, please. Installation destination. So basically here we could partition disk, create partitions and so on. Please make sure that this option automatically configure partition is selected. So basically we give authorization to this installation process of CentOS to configure partitions for us. In this case, it's good, it suits our need. Optionally, we could select this option to encrypt my data. It means that when our disk is lost somehow, and for example, if a malicious person that have stolen, for example, our disk, plugs this disk into other computer, it will not be able to see anything. But for this purpose, we're not going to use encryption, because we are not going to get ourselves into such situation. And also, the encrypting the data is a time-consuming process, so we're not going to waste time on this for this particular purpose. So click Done. And now when we configure the partitions, we should have this button Begin Installation available.
Should we set up the network?
No, because, okay, you could come, we have this Ethernet adapter, that's like our network interface card, and everything is fine for now.
And then you can click on the connected
You have
on-off switch.
Okay, maybe, yes, okay, good. So it's connected, okay, good. So, as I told you, later on we're going to discuss about this Oracle VirtualBox virtual network modes in detail, but for now we chose, when we have been configuring our virtual machine, we chose the option Network Address Translator, which is by default. It's like a default option. It means that by using Network Address Translation Network, we are able to connect to the Internet, and that's what we actually want to do. Okay? So click on this Done button, please.
It just says no disk selected.
Installation source. It's here.
No, down. Down.
Begin installation. It works.
Oh, okay.
Just begin installation. Okay. So, what do we know about Linux partitions?
So like different types, the home directory, mount.
These are like directories. However,
Yeah.
okay, while this is being installed, okay, first please let's set up a root password. Root, you know what is root? A root is like a super user of the Linux system. It's like the most important user. On contrary, in the Windows world we have administrator. But here we have a root. Root is like administrator of administrators. It's like the main administrator user. And now we could like create a new user. I'm going to create user for myself. Like username will be Nebojša. And I'll set up my password. And yes, I want to be administrator, yes. But this user is different from the root user. Root user is my administrator as administrator, but basically most commands that we can run by using this administrator user context, we can, most commands we can run, we are able to run by using the root user context. We can also run by using this regular administrator user context. So basically there is no such a great difference. Instead of that, as you know from the Linux environment, when you are logged in as a regular administrator, so not the root user, if you want to run any command by using administrator privileges, you have to type before the command sudo. S-U-D-O, it means super user do. However, when you are logged in with the root account, which is not recommended due to security reasons, of course, you are able to run commands in administrator commands without typing the sudo command. So basically that's the most important difference. And also relating to security, it is extremely important that for each service you create your own user. Like in the previous exercise where we installed this WordPress, and by using the MySQL database, we have created a separate user for this database. So we did not, when creating the WordPress database, we did not utilize privileges of the root database user. It's the same here. When we install a service, some kind of cloud service in Linux, for example, we want to create a user for that service and to assign appropriate privileges, but only those privileges that this user must have in order to successfully complete a particular task. You get it? So this is very important security concept I want to tell you. This concept is also applied in the cloud environments, and this concept is named the concept of least privileges. So remember this, the concept of least privileges. So the concept of least privileges states that we should give only necessary privileges to certain user that are needed for that user to perform certain tasks for which this user is responsible. For example, if we have like a user who is responsible for the web server on our system, we should assign only privileges related to this web server to that user, not privileges related to like the maintenance of the whole system or like DBA, database administrator, or some other service administrator. So we must assign only those privileges that are needed for this user to successfully accomplish a certain task. That's it. Okay, please begin installation. Okay, good. Okay, so let's continue with this. Okay, so we've defined the password for the use user, and we also created a user. So this installation process is still ongoing. Okay, I'm going to use my connection here. So what do we know about Linux partitions? What can you tell me about that? So what are partitions in the first place?
It's like a segregation of like how you want to segregate your memory space.
Yes, basically, yes, it's segregation. So basically we divide a physical disk into different number of logical partitions. So does this seems familiar? It's also some kind of virtualization, because you are dividing something physical into logical chunks. Okay, so and what is the basic difference between the roots in Windows, the partitions in Windows and partitions in the Linux system?
In the Windows, I think it's divided into like C drive, probably the D drive, not sure. But in Linux, we have like the home directory, the mount, the
Okay.
In Windows, we have it all in one directory, and we don't go to it.
So in Windows, mostly we can have like one or two partitions. For example, one partition for the operating system and the second partition for user files. But however, that what you like just called like C drive, E drive in Windows and so on, okay? These are like, these are called mount points. These are just access points. These are just access points to access our partitions. And in Windows, for those access points, we use simply drive letters like C, D, E, F, G, and so on. However, in Linux system, instead of using drive letters, we use directories or folders.
Yeah, exactly.
But that folder is a mount point, so that's the basic difference. So instead of using alphabet letters, like in Windows, in Linux we use directories as our mount points, and those mount points are we just use for accessing a certain partition. Okay. Okay. So we still, and there is one special partition in Linux, which is called swap partition. So what is swap partition?
Think of it like as extra memory. So for example, remember I'm using that.
What is swap?
It's kind of an extra memory.
Kind of memory.
Extra memory. It's
Extra memory. Extra memory. Yeah, extra. Yes, it's virtual memory. You know what's the catch? Let me explain, because you should know all this. So what is, by definition, what is the virtual memory? What is the virtual memory? So the virtual memory is like when we expand our actual random access memory to the physical disk. For example, look here. For example, we have like 8 gigabytes of random access memory. And in Linux, we create additional swap partition, which can be accessed with this mount point, so /swap. And we delegate to this swap partition 4 gigabytes. Okay, so tell me, these 8 gigabytes belong to the random access memory, and this other swap 4 gigabytes belong to the physical disk. It's simply one file on the physical disk, nothing more. What is faster, disk or random access memory? A million of times. So it's a bit different. So what happens? For example, look here. For example, here we have some kind of program on our disk. It's executable, it's application. So what happens when we want to run our application? This application first must be loaded to random access memory. You know why? You know why? Because this application has to be executed on the CPU. And CPU can only execute applications that are in RAM memory. It cannot execute applications from disk drive. So first we, for example, click on this executable. It's some kind of application. And then this executable is being loaded into the random access memory. And as soon as this application is loaded into the random access memory, it becomes a process. You've heard of process?
Yes.
So it's a process. So by definition, process is application or a program that is executing. So that's the definition. So in order to distinguish between the programs that are on the hard drive and the programs that are stored in memory, a third process is introduced. So basically, that's this process, but this program, but now it is in random access memory. Okay? So, here, for example, at the right we have a CPU, and CPU communicates with the RAM memory, and in this way, this process is being executed on the CPU. So very simple. So, every operating system is sophisticated. It consists of many processes. Many processes. And especially if we, on top of all that, we have like other programs to run. So we have many applications. So we can, by using the concept of multi-programming, we can run many applications simultaneously. Is this right? And also we may have like many users on a system where each user runs a lot of applications and so on. Please click on this rebut button when this is finished. Okay, so we have all such kind of things. So at some point of time, it may happen that all these processes that are executed in memory take, in our case, all 8 GB of random access memory. What happens then? Then some of the processes from the random access memory, because all available capacity of random access memory is being taken by the processes that are running. Some of those processes are copied to this extra memory, swap memory or virtual memory on the disk. And now this memory on the disk is being considered as a random access memory. However, what are the drawbacks of that?
This time,
The system is executed extremely slow because hard disk is okay. I'm going to neglect solid state drive, but in most cases hard disk is mechanical disk, so it's millions of times slower than the random access memory. So our system becomes sluggish, it becomes slow, irresponsive, and so on. You remember hearing your mechanical disk like working? Yeah, that's it. So
no more of that.
okay, so we have a swap memory, but what do you think? What do you think it would happen if we take all the available space of random access memory, and if the swap memory is not available, if we do not have swap memory, what would happen? No.
The system crashes.
The system will crash. The system will crash, and in Windows, in such cases, we have this.
Dead screen or something.
Yes, we have this so-called BSOD, so famous abbreviation, blue screen of death, which is not good. And then we should check up for those error messages to see what's wrong with our system and so on. And in most cases, when we see a blue screen of death, it's the problem with memory. However, you should have learned that in architecture, I suppose that you did. However, in some cases, when you see blue screen of death, so please always read this error message and Google yes, search it. In some cases, it could mean that some of your components of your computer is going to fail, like motherboard, probably CPU, or something serious. So please read those codes and check it. But in most cases, it's simply the problem with the memory. So you know that you have to do what? Either to buy additional random access memory, if your motherboard supports like additional memory, or you will have to expand this swap space. You know what's the optimum of the swap space size? Optimum. Like there are different metrics, but for example, with the systems that have 4 gigabytes or less RAM memory, the optimum value for the swap space is to be when you multiply your random access memory by 1.5. So in this case, if we have like systems up to 4 gigabytes, in this particular example, if we have a system with 4 gigabytes of random access memory, optimum size of the swap space would be 6 gigabytes. However, if we have more than 4 gigabytes, according to some metrics, analysis, and so on, optimum space would be just 4 gigabytes, or let's say 8 gigabytes multiplied by coefficient of 0.5. So it will be like 4 gigabytes. So we have like 8 gigabytes of random access memory and 4 gigabytes of swap space. We have in total 12 gigabytes of virtual memory available. So it's then virtual. When you mix physical and virtual, we get virtual. It's not real. It's not physical. It's not what we see. It's something like more than that. Okay? Okay, so let's continue with this. I hope that the installation is finished. Okay, so let's log into the system. I'm going to log with my user account. Did you log in?
Yes.
Okay, so first thing that we are going to do, so you know Linux machine is so-called, in most cases, is so-called headless machine. It means that it does not provide graphical user interface. We said why? Because the graphical user interface takes a lot of resources. So imagine that it is just a server without graphical user interface, just a server. So first, we would have to connect to this server from some other computer, which has a monitor and everything. Okay, in most cases, servers even don't have monitors. They're just sitting there in the rack without output device. First, we'll have to somehow connect to our server. Okay, we can use this VirtualBox console, but let's pretend that we do not have this console. Okay, so the two most commonly used ways to connect to the remote server or the remote machine. First, there was a telnet. That utilizes port 23, you should know that. So first it was a telnet that utilizes port 23. And this telnet is abbreviation from the concept of mainframe computers where we have terminals, we mentioned that. So one huge drawback with telnet is that it is not secured. It means that every time when we connect to server by using telnet protocol, and when we exchange the data, this data that is being exchanged is not encrypted, so a malicious person can intercept communication and read our data. So in these modern areas of computer science, the telnet is like deprecated, so it is not being used anymore. Now we use SSH, as David said. What does the SSH stand for?
Sure, secure. No, not sure.
What?
Secure shell. Nothing more than that. Secure shell. And it's the same as Telnet. It has the same purpose as Telnet. However, instead of using unencrypted connection to connect client and server, SSH uses encryption. And it uses a pair of private and public keys, in most cases RSH keys, but we are going to work with that later exercises.
RSH or RSH?
RSH, sorry, I made a mistake. Yes, RSH each, yes, of course. Reverse channel addendum, and this is like one of the most utilized encryption protocols, as you know. And it uses which port?
8080.
No, it is the deprecated web server port, 22.
22.
Okay, it uses port 22. So, very good. Okay, so, however, if you want to connect via SSH, secure shell, to our Linux machine, first we have to install SSH server that will listen on port 22 for the what? For the incoming connections. Okay? Okay, so let's do it. So since this user is not root, it is administrator user with administrator privileges, but it is not a root user, we have to use the sudo command. And then this CentOS operating system, it emerged from Red Hat Linux. It uses so-called yum installation package. It means it uses yum command. It's like standard command for installation. And then in this case, we want to specify this argument y to install. And now we should specify which software components we are about to install. We're going to install open SSH-server and open SSH clients. I'm going to install both components. And just click enter. And now, since we are executing this command with sudo, every time we should specify password for administrator account.
You put minus between open SSH and
Server, yes, it should be minus. But what does it say? It says that it cannot be found. Oh, sorry, I forgot here install. So just, I'm going to clear screen. Just use up arrow on your keyboard, and after that Y, just type install. That's the command for installation, sorry. Okay, enter. And now it reads from which part, from where are we uploading these files? We're retrieving these files from the so-called Linux repository. Okay? Do you remember when you learned Linux? We can configure Linux repositories. They are like online repositories, sources for Linux software. And we have a special configuration file where we list all available repositories. So when we type the command like this, that we want, for example, to install OpenSSH server and OpenSSH clients components, our Linux first searches repositories to see whether these components are available, and if they're available, they have like URL, Uniform Resource Locator address of this repository, and it simply retrieves files from this location. So very simple, okay? Now, I'm going to clear the screen again.
I cannot like the line that says open SSH server does not exist.
Okay, let's see. You have already installed it. It's okay. Okay, so so let's please now do the following. So let's use this CentOS command. So basically, in the world of Linux, as you know, we have two major distributions. We have Debian-based distributions and Red Hat-based distributions. Debian-based is Ubuntu, one of the most important representatives, and this is example of Red Hat-based distribution. So we use slightly different commands. So let's check now whether our SSH server is running. We just type sudo systemctl status SSH and it says that SSH service, SSH daemon, I apologize, SSH daemon, because it's a daemon. You know what's a daemon? It's a daemon like a service in Windows. So service is by definition a process that is executed in the background. So this process does not interact with the end user. It simply executes in the background. So when we are in the world of Windows, we would say service for such a process. However, in the world of Linux, we would say it's a daemon for such process. Okay, so basically all processes in a Linux system that are executed in the background and that do not interact like with the end user, these are called daemons. Okay, and this daemon is just spinning in some kind of loop. It spins, and it listens on the port 22 for the incoming connections. You get it?
Yes.
Okay, good. But now we could like sudo systemctl restart sshd. We could like restart this daemon, and now I again want to check whether it works or not. Also, okay, so only a few things before the break, please. Just a few things. All services in Linux are starting by default upon the computer is booted. So when we boot up the system, SSH will start by default. If we want to disable SSH for starting by default when our system is booted, we could use the following command: sudo, but do not run it, please. Systemctl disable SSH daemon. In this way, when our system boots up, SSH daemon will not boot with the system. And of course, later on we could use like enable. Yes, okay. Just remember these commands, it will be very useful. Where SSHD, of course, is just the name of this service. For some other service, we would use like something else. Okay, so if we want to make our system more secure, okay, that's how real cloud systems are configured. We would like to disable the root user to be able to log in to our server via SSH protocol. So it's like some kind of security measure. It's okay measure, it's good measure, and you could do it, you should do it in order to make your system more secure. So for this purpose, we have a special configuration file that we can edit. So we type sudo, and then we type nano. Nano is one of the, let's say, most user-friendly editors for Linux, and we just edit the file which is in ATC configuration directory, SSH folder, and the file name is sshd-config. That's the name of the file.
ATC.
ATC, yes. It's like configuration folder, sshd-config. Okay, and we don't have nano on this system. We should install nano. Okay, it does not come by the basic CentOS package, but we could use like Vim editor. Vim. Okay, we are not having nano on this CentOS, but we can use the Vim editor. Okay, please hit enter. We also don't have Vim editor. Okay, after the break, we are going first to install the editor. That's why we use the minimal CentOS configuration. Okay, but after the break, we are going to install this Vim, okay? And then we shall continue. So we need some kind of editor to edit the files. Okay. Okay, so let's continue after the break, please. So since we've established that we do not have any editor on our system, let's just install the nano editor. It's a very user-friendly editor. So just going to type sudo yum install nano. And again to hit my password. Just click Y, but lowercase y, because you know Linux is completely case sensitive. It's complete. Okay.
Now we execute the command.
Yes, now we'll execute the command. We're going to edit this SSH daemon configuration file. Because we don't want to allow the root user to be able to log in via the SSH console. In this way, we make our Linux system more secure. So just type sudo nano etc ssh/sshd_config. And here you see that, find this line of code, permit root login. Okay, you can just search it, but it's basically, you know, just go 2 screens below and you'll find this option. It's under the options authentication.
I found it, maybe?
Okay, I come to you. Yes, I understand this comment. Permit root login. Okay, so in all these Linux configuration files, when you see that a particular line of code starts with a hashtag, it means that this line is like commented out. These are live comments, okay? So first we want to remove these comments. So please remove the comment and just here say that we do not want to allow root user to connect. Okay, and just click yes.
How do we save it?
How we didn't save? Sorry, Control X, and then just type Y.
Control O and enter. Ah, okay.
No, like this. You see, you go here. So, for example, I'm going to change something. Control X, and then just type uppercase Y, and enter. Did you manage it? And then just please type this command.
Yeah. And then Control S.
And just type this command because after we change these settings, we want to restart our SSH service. Enter. And just type this, please, to restart SSH service.
Oh, I can see it.
Sudo system CTL restart SSH server. CTL restart SSH daemon. I wanted to share the screen with you, however, I would consume too many of my users. Okay, and there is also one more security precaution that we want to take before connecting to our Linux and everything. Since we use this CentOS 7 minimal installation, we don't have any firewall. Okay, we should add a firewall service to our system. So, for that case, for this purpose, just I want to restart it. Okay, so let's install firewall. We type sudo yum install firewall d, like firewall daemon. Okay. It's only 844 kilobytes. Okay. So, by default, the firewall blocks all incoming traffic. So we would not be able to connect via SSH to our Linux system, and now we have to configure the firewall to let some services to come in, and one of these services is SSH, and later on we will also need HTTP. That's for our web server service. So please always, when you configure Linux system, especially for cloud services, install and enable firewall, and then allow certain services to pass through this firewall. Okay, So let's do it. In order to enable certain services to pass through the firewall, we simply can use firewall cmd command. It's very easy. So I'm going to clear the screen. So basically we just type sudo firewall hyphen or dash cmd. And since we want to allow these services to pass through our firewall permanently, we should use the permanent flag, but with double hyphens, double dashes, permanent. And then finally, we want to add the service with hyphen hyphen add hyphen service and equals SSH, because we want to allow SSH service to pass through our firewall. Okay. Okay, success. So please note that. So please note that if in this, by using this command, we allowed SSH service to enter to our Linux system by using the default port 22.
Professor Virsaro is just logged in and started teaching the codes now.
Okay, but can you work?
Yes.
Okay, it doesn't matter. Okay, yeah, here he is. Okay. Okay, so now we enable the firewall to accept SSH, but so note this. By using this command, we allowed this SSH service as inbound connection to our Linux system by using the default port, which is 22. If we want to add custom port that can pass, if we want to add some other traffic to pass through our firewall by using some kind of random or custom port number, we could type like this. So let's just, I just want to show
The
you.
previous command didn't work.
Sorry?
We can't, the previous command didn't work for us.
With this,
Dash somewhere around
this. So he's here before permanent we use double dash, double hyphens, and before the add argument as well we use the double hyphens. Okay. Please try it. So please know this. If we want to add the traffic by using some other port through our firewall, we should type like that. David, can we? Is everything okay? Okay, we could type like this: sudo, again firewall -cmd, add, then port, and we just specify which port. I'll just write like port 8888. Do it because it's safe. We are not going to deploy this system into production environment. And then / we want to say which protocol. So we want to use TCP protocol, because you know what's TCP protocol. It's on the internet or network layer, TCP IP model protocol. Okay, we can do it, but in this way we allowed incoming traffic, incoming TCP traffic with port 8888 to pass through the firewall and to get into our system. Okay, that's something just I wanted to show you. And now let's add some other services that can pass through our firewall. These services are related to web server. So I'm going to clear the screen. Is it okay?
CMD double dash add dash port dash 888 slash TCP.
Yeah. So in this way we allow port. We open the port 8888 with TCP protocol. Does it work for you,
Yeah.
Stefan? Oh, Sinisha?
Yeah, it will be Stefan.
Sorry.
Yeah.
No, Stefan, I said.
Yeah, then you change this.
Oh, crazy. Sorry about that.
I did not work for
David? Oh, let me check, please. See where the hyphens are. We have only two before add, then we have that. You put hyphen, it's important.
It's a hyphen.
Sorry. Yeah, there is no hyphen there. Yeah. Oh, you cannot see. Okay. It could be like or without anything, just blank, or with equal sign.
Is there any way to enlarge the display?
You have to restart it.
Okay, no. Let me connect. Share the screen. Okay.
No problem. On our displays. On our laptops, computers.
On your computers. There is a way, however, this way will be when we connect via SSH. Okay, that's exactly what I'm about to show you, but first let's finish this, please. I'm going to clear the screen, and now I'm going to allow HTTP and HTTPS traffic through our firewall. That's for the purpose of web servers. So again, sudo firewall -cmd double hyphens permanent double hyphen add hyphen service equals HTTP. Now we allowed HTTP service to pass through our firewall. And now just add please HTTPS.
So same just to test.
Yes. And now just add SMTP, for example. If we want to, for example, allow outgoing emails to go through our firewall, but we're not going to implement the mail server. That's something what you will do maybe for the final project. It will be interesting on AWS, for example. Why not? What do you think about that? It's interesting, yes, because now we are implementing infrastructure services. So I told you already the basic idea behind this course and the course in the next semester to make you so-called DevOps. You know what is DevOps?
I have to say that it's all-rounder.
All-rounder is the person who knows how to set up the infrastructure as well as how to develop the services. So in the next course that we're having in summer semester, we'll learn how to develop web services, RESTful web services in Java and Spring Boot technologies. And then we will deploy those web services on AWS infrastructure by using Linux terminals like that and virtual machines in Amazon. So in this way, we connect three areas. We connect cloud computing. We connect, yes, of course, we connect development, SQL fault-centered development, and we connect infrastructure, which is this Linux and virtualization and everything. So it's like a DevOps. It's not so bad. It's not so bad, really. You should know this. Okay. If we want to see which services are allowed through our firewall, we could enter the command like that, like this, sudo firewall -cmd double hyphens permanent double hyphens list -all. And now we can see, you see here with this services label, we can see which services are allowed through our firewalls, okay? And you see, as we like type this add, we could type remove, and in this way we will remove certain service. Okay, but we're not going to do this. This, what we are doing now, belongs to the job role of server infrastructure administrators, okay? And now, when we configured all these things, when we allowed all these services to pass through our firewall, now we have simply to reload the firewall rules, because only this way these rules will be applied. So we type sudo firewall -cmd double hyphen reload and finally we want to enable this firewall service to boot when we boot our computer system. So we type sudo systemctl enable firewall D, like firewall daemon. And now when we restart our system, the firewall daemon will be up and running. Okay, so I'm still not going to install a web server, because first I want to make a remote connection to this machine via SSH. But first, what do we have to do? We should know the IP address of this machine. So, if you can recall, we said that this computer goes to the internet by using the network address translation type of network adapter. This adapter is like, you know what is NAT? Never mind. NAT, yes.
Ethernet enables us to connect to the internet.
Okay, I'm not going to go deep into this because we have a whole topic devoted to this. However, this I just want to say that this for this time. This NAT enables multiple computers within the local area network to share the same public IP address. As you have, for example, your home gateway, your home router. So all devices that are connected to your home router, they have the same public IP address, and this is the address that they use on the internet. However, behind your firewall, each of these devices has its own unique private IP address. Are you familiar with private IP addressing? You know. The same is here. This Linux machine, when we go to the internet with this machine, you will have some kind of public IP address, However, this machine is behind this NAT component, so it has a local IP address. How can we check this local IP address of this machine? Again, we are going to go deep into this subject, into this topic, and we are going to discuss it in deep, but for now I'm not going to elaborate more, okay? We're going to discuss about it. So, if you want to connect from the outside world, from this our Windows host machine to our virtual machine, first we have to see what is the private address of this machine, so the address that is behind this NAT component. So let's simply execute ifconfig command. We have nothing on our Linux system. Okay, please, so first please check if the internet works. I'm going to pick Google. It works. You know the ipconfig command, like in Windows. Are you familiar with this?
Yes.
Okay, so just Control C to stop this. We could so install the ifconfig, or we can just simply type this command. It's easier. IP address show. Okay, it's much easier. I got used on Ubuntu and Debian based systems. I'm not from the Red Hat world. So IP address show. And please see this. You see this inet. And this address 10.0.2.15.
Yes.
Okay, so it means it uses a 24-bit subnet mask. So that's our private IP address.
The public show others.
Sure. No, just space show. Yeah.
Yeah, I understand it very deep.
Okay. Okay. Now, so remember this, in VirtualBox virtual environment, all machines behind the NAT component have the same private IP address, which is 10.0.2.50. Okay? So that's our private address. Okay? And what did we say? Which port SSH uses?
22.
22. So please look at this diagram that I'm about to draw, please. Again, I'm not going to go deep now, but just basic things. So here we have this NAT component, which is also called in the literature as NAT box, network address initialization box. And our Linux machine is here, and it is connected with this NAT component with some kind of network interface card. Okay? And the private IP address of our Linux machine is 10.0.2.15 with 24 subnet mask, 24 bits subnet mask. Okay? So this is private address. Why? Because it is on this side on the net component. However, at this other side of net component, what do we have? We have our Windows PC. So it's our host operating system, our main host or Windows, and we also have like internet. Okay. So, what do we want to do? What do we want to accomplish? Imagine that there are many computers on this netbox. Imagine that behind this. There are many computers, and imagine it's not how it is in VirtualBox, but just imagine it, okay? That all these computers have same different IP addresses, private. 216, this is 217, and so on. It doesn't matter. So we want to access this particular host from our Windows operating system with this network address translation box. More precisely, we want to go to this Linux by using the port 22. So now imagine that all these systems have SSH, they all have like open port 22. How can we connect directly to this computer? By using the technology of port forwarding. Port forwarding. What does it mean? It means the following. For example, look here. Please. If we want to connect to this machine, we specify on this net box so-called port forwarding rule. Port forwarding rule which states the following. For example, if we connect from this Windows host to this network address translation box to port, for example, 3333, that's some kind of random port which must be greater than 1024, because ports below 1024 are well-known ports that are reserved for well-known services like HTTP, SMTP, IMAP, and so on, okay? So we want to say, when we connect from this Windows host to netbox to port 3333, okay, we are forwarded to host with IP address 10.0.2.15 and port 22, because that's incoming SSH port for this machine. Do you get it?
Yes.
That's called a port forwarding technology, and it is very useful. For example, at your home, you may like open your PC, configure a web server, and then on your home router you may establish this port forwarding rule. So when you type your public IP address, your home public IP address, and certain port number, you will be forwarded or directed to this Windows, for example, machine at your home on which you have a web server up and running. Okay? So again, for example, another example, when we connect to this net box, and when we type port 3333, we are forwarded to the host or the Linux with IP address 10.0.2.15 and to the port 22. Okay? So in order to connect, we need to establish such rule. However, we also have to know what is the IP address of this net box in our case. What do you think? What would be the IP address of this NAT box?
10.0.2.15.
That's private IP address, something else.
Ah, okay. 127.
Yes. The net box has address of so-called local loopback address. That's the address of our local network interface card. 127, for example, 0.0.0.1. Okay? Let's do port forwarding for this virtual machine and this network adapter. So how do we do this? So, please go here to our basic VirtualBox interface. right click on the machine and choose settings. Go to network, choose this adapter 1 with net, of course. Go to advanced, choose port forwarding, very easy. So this is very useful technology, you should know this. This is something so much frequently used on the cloud, really. So click add. So which protocol SSH uses? It uses TCP, because we have TCP and UDP protocols on the network or internet layer, and since SSH is reliable, SSH needs a reliable network layer protocol. This is TCP. So we could name the rule. I'll name the rule like SSH access. And then first in this box, host IP, I type the address of this NAT box. It's a local loopback address, 127, for example, 0.0.0.1. And now this is the host. Now we choose the host port. We could choose the host port randomly, but we should memorize this. And this port will be like higher than 124. I'll use the port like in this example, 3333. And guest IP is this IP behind the NAT box, private IP address, 10.0.2.15. Okay, Georgi, are you okay?
Yeah, that is the same for everybody.
The same for everybody, yes, for everybody. Because all machines behind NAT in VirtualBox have this IP address. And then we specify the guest port, and the guest port is this SSH port, which is 22. Okay, a guest port is 22. Did you do it?
Yes.
Very good. Is 10.0.2.15. And the guest port is 22. Okay? Very good. Click OK. Click OK. And we don't have to do anything. It's all done by us. So, now let's go to our Windows host. Now let's download the Windows SSH client. There are many clients available. And for this purpose, I'm going to use a simple PuTTY client. Very good client, and portable version. That's the version that we do not have to install. So I'm going just to go to the Google briefly, and I'll type like PuTTY download Windows 10, for example. So PuTTY download Windows 10, and I go to this first link. Okay. Internet not so good. Yeah. Okay, can I go here?
Yeah.
And now you see here we can download PuTTY here. Just click here. And now I should search for this portable version. So I'm going to use portable. Do you see any portable versions here, please? Okay. Here are portable versions, all are portable. Just click here on this PuTTY, 64-bit, and please run it. Here's the putty client. Okay? Are we good? I'm going to pause now because a break is coming. Continue, please. So now we simply, by using this putty client, we will connect to our Linux system. So very easy, okay? So for this host name or IP address, we put the address of our NAT box. So local loopback address, okay? 127.0.0.1. Stefan, good? Yes, so local loopback address. So we basically connect, you know why? Because this putty is here on the right side with like our Windows host. So from Windows host we cannot see our machine. So we can see only the NAT box. So we have to connect to this NAT box, and then by using the port forwarding rules, this NAT box will make this connection for us. So basically that's it. So, but for port we again have to put the port that we have defined in our port forwarding rules. It's 3333. You get it? So this is very important concept to realize. You didn't do this on computer networks.
No, mostly theory. It was just
Okay. That's why we're doing practice. I want to I want you to have the complete knowledge. Really. Sorry? So?
It's worst course of network I ever saw in my life.
Oh, but it's maybe.
We didn't learn anything after listening.
It's boring. Okay, so you want to. Yes, but here we do like theory practice, and we have a lot of things to cover, but unfortunately we don't have like so much time. Yeah, there are a lot of things really here. So click open, and now it asks us, since this is the first time we are connected to this host, this guest computer, this Linux machine, it's like a stranger machine, let me say. So this putty asks us whether do we trust this machine. We say yes, we trust it, and now we can log in as this administrator user. You know why? Because we denied a root login in this SSHD, okay, due to security reasons. Okay, good. Nice. Okay, so, let me check. Okay, exactly. See everything. Okay. Oh, so just yes, because we trust this machine. You see, now you log in with your administrator account, but not with root because we denied root. And you should send me this presentation to our okay.
So I have.
It has to be password.
Did you forget password?
No, I didn't even put password. No, I clicked.
Installation?
Yeah, I clicked identity password.
You put password.
You have a box there where you put.
Okay, let me say. Okay, just a second.
Right.
How computing is really important. That's really computing. Can he just add up, because I have like explanation of the work, could he add on this, because he has also presentation.
Yes, but you don't have for today. Also, you also for today. Oh, okay.
You just need to type
as a
it.
basic and like make conclusions and continue.
Oh, yes. It's completely fine. Thank you so much, really, for your hard work. And it's closely related to the syllabus, so you basically work. Oh, Stefan? Okay, maybe you can put local host. It's the same. It's the same, yeah. Open. Yes.
Yes.
Just enter it. We didn't put. But you have password set.
Yeah, I first put root and then I clicked on the password, but when I type in root, it again says access.
Okay, let's see. Outside. How are you connected? Haven't typed your password. Just with PSWSWD. No, make a new password, please.
You didn't.
Yeah, that's like the best. Really best.
Are you sure that's you didn't?
Yeah, of course. I'm sure now that that's why I use the phone.
Okay, yeah, that's good. So let's
And
try
I
it.
should-
Please come. Excellent. Let's continue, okay?
Yeah, I sent him the mail to
Okay.
my password.
So, Georgia, it works. Okay, so now, as Georgia asks me, we can right click here and change settings, go to, I think, appearance, and here, font settings, I will enlarge those fonts for a little bit like this. Okay, I think now it is better. Okay, so now let's install and implement our web server. It's HTTPD like HTTP daemon. So just type sudo yum install HTTPD. And again, I type my password. Okay. Did you type password?
Yes.
Hit enter, please. And now the web server is being installed. I type Y. It's 10 megabytes. Oh, it's too huge, but okay. Complete. And now, for just in case, I want to update this HTTP daemon. Maybe there is even a new version from your repository. I'm just going to clear my screen. I type sudo yum update HTTPD. Okay, there are no packages marked for an update. Okay, now let's start HTTPD. So let's, Georgia, is everything fine?
Yeah.
So I'm going to clear the screen once again. So let's now please start now our HTTP daemon, now our web server, sudo systemctl start HTTPD. And I want also to check the status. Is it working properly? Sudo systemctl status HTTPD. And we see this active with highlighted with yellow, with green. It means that our server is working properly. Now tell me please, on which port does the web server listens for incoming connections? Web server got 80. 80, okay, 80. HTTPS uses SSL certificate, secure socket layer certificate, and port 443. But for now, we are not going to use this HTTPS secure web server. We are using regular. Oh, sorry. We are using regular web server. Okay. So, look here, please. Again. So, how can we access our web server?
Port forwarding will.
Port forwarding, of course, will not. Again, the same reason. Okay. So how can we configure port forwarding now in this case? What can we do? We want to connect. Look here, from this Windows host to this Linux machine, okay? And we can say, for example, when we hit this NAT box, so when we hit this local host address or local loopback address 227.0.0.1, okay? And port, for example, now we make our own port, which is again greater than 1024, because ports below 1024 are known as well-known ports for the well-known services. They are also called ephemeral ports. Maybe you heard of that term. Ephemeral ports. It means that they're stable, they're like reserved for well-known services, okay? Like, I already mentioned 80, 443, 3389 for remote desktop protocol, and so on and so on. So we are not allowed to use those ports. These ports are forbidden. You'll see on AWS platform this as well, because we are going to do this all on AWS, okay? So when we hit, for example, our NAT box and port, for example, 5555, okay? Maybe that be our port for web server. Then we will be forwarded to this machine, and which port? 80. Okay? Why 80? Because it's the default web server port for HTTP daemon. However, we also can change this port, web server. We can change 80 to whatever number we like, but never do this, please. It is very bad practice. You know why? Can you imagine if you like set up your website on some web server that uses like random port, like 3232? You know, in that case, do you know that? Let me show this. Let me show this, please. For example, when you go, I want to go to Singiduno. Oh no, I want to go to Google.
8080.
Okay, by default, we should type like this, port number 80. That's how, but Google is secured, it's 443, okay. You know, when we go to every website, we should type like, after the DNS name, we should type : and then the port number. HTTPS uses 443, and we hit enter. However, the web browsers are configured in a way that we do not have to do this, because they append this port number for us automatically, because they use well-known ports, 443, 80, and so on. So imagine if we like establish a site on our web server, David Praise. Did I pronounce well?
Yes.
Oh, Praise. Okay, good. And imagine if we like set up the port 4444. Then when, I don't know, I type, David says, please look at my site, I have my new like photos, my projects, my everything, come. And David, for example, set up like port 4444 for web server. Then when user types like davidpraise.com, maybe there is, okay, davidpraise.com, okay, we can buy for $300, oh yeah. Okay, for example, when user types davidpraise.com, it will automatically be like it's using port 80. And this, the user will not be able to access this. So the user in that case would have to type like davidpraise.com, 4444, that would be crazy. Okay, imagine that David is running a company, his own profile or something, and he says, please go to my website by using DNS, David Praise, 4444. Oh, it would be too annoying, okay? So that's why it is a very good practice it is very bad practice to change default port numbers for well-known services. Okay, simple as that. Okay. Am I boring with all these facts? Okay.
Well, this is like very interesting now. After learning computer networks and seeing all of this, makes sense now.
No, but there are a lot of things, but we don't have time. It's not computing yet, but okay. So, so let's now configure the port forwarding rules for this web server again. Right-click on our machine. Okay, and go to settings, please. Just go to this network tab. Please go to this advanced. And now port forwarding. Just click plus. Let's set up, define the name for the new rule. Oh, sorry for that. It's like a web access. Please name the rule as you like. In my case, it's web access. And again, as in the case of SSH, when we type 127.0.0.1, so when we are referring to the local host and to the port 4444, we are actually going to the Linux machine behind our NAT box with private IP address of, again, 10.0.0.2.15 and the port of 80. Okay? Okay, and everything is set up. So our machine is running, so everything is good. Now, how do we access a web server? How do we access it? From any machine. By using a special programs called web browsers. Period. So, I'm going to open my Chrome, and I'm going to test connection to this web server. David, are you good?
Yes. I was on an error. I put double zero instead of 1 0.
Okay. So I just type like 127.0.0.1, and then this stupid port number, which is 4444. I think which port number did we use? 4444? Colon, always, because it's a universal syntax according to the specifications of organization W3C. You heard of that organization, World Wide Web Consortium. That's an organization that maintains and takes care about the web services, standards, and technologies. Okay.
Testing 1, 2, 3.
Okay, it works. Excellent. It works. So, there are a lot of things I want to tell you, but there is no time. A lot of things, really.
I don't see if you do it for here because I forgot my glasses.
Yes. Oh, yeah.
It's a bit hard to see, so that's why I'm always
I
asking.
didn't share the screen with you. Okay, but next time I'm going to share the screen.
You can look through my computer.
You know, this other laboratory there is not so big, so you can see better from the screen. Yeah.
Oh, we can see from here. I don't see good. I don't see good anyway. So
You forgot glasses.
yeah.
That's good, so you can afford to forget, because
Yeah.
yeah. Okay, so just please go to terminal. Do you know what is the root of web server? It's like the first page that opens when you connect. Like home, yes. It's usually index page. However, by using the new HTTP specifications, from HTTP 1.1 version and onwards, like today is the current 2.0 version, we can set up so-called virtual hosts, but I'm not going to show you that right now. What does it mean? It means that on one web server, we could host many domains. That's awesome. In the previous HTTP specifications, like 0.1 or 0.9, we were not able to host many domains on one web server. We could host only one domain. So per web server, only one domain. Now we can host many domains on one web server. It means like we can host, let's say, idunomacy.rs, we could host davidpraise.com, we could host nebojshabačin.rs, Stefan Čulović.rs, and so on. So it's very good. And this type of hosts are called virtual hosts. Because under one web server, we can have as many hosts as we like. But that's a different topic. I just wanted to mention. So the root of web server in Linux is in the, we go cd change directory. It is in the /var/www folder, /var/www. And here, if I execute the ls command, okay, let's go again to this HTML folder. Okay, so basically all websites that we want to implement to this web server, we should copy files here because it is the root of our web server. So let's test it. So when we are in this HTML folder, let's just create a simple HTML file by using the nano editor. So nano, I just type sudo nano, and then let's create our web HTML page like testpage.html, for example. So testpage.html. Just briefly, and I'm just going to type very simple, plain simple HTML page, like with h1, test page header. That's it. So, very simple page. Very simple HTML code. Okay. Test page.html. Just type this simple HTML code. AWS Education Institution registration is finished. So I'll give you next week access to other accounts. Okay, did you write it? So Control X and Y, uppercase to save it. So we put this, if I go ls list command test page is in our root directory, so we should be able to access this test page. So if we type like this, so after that slash and we type test page.html, you see we get our page. So everything works fine. Okay? Okay, good. So I'm going to finish this here. So I already have a tutorial on YouTube with CentOS configuration web server, but in another hypervisor called VMware Workstation Pro. I'll post a link. So we're not going to do the same example again in another hypervisor, but I'm going to post the link to the tutorial. Okay? So next week we continue with the theory, but aggressively.
Right.
Okay. But before Strahinja and Georgije deliver presentation, just a second. I'm going to stop recording here because we finished.